predicting physical properties. So, how did Mendeleev predict the properties of those elements that they didn't know about yet? Well, we can make reasonable estimates of physical properties by looking at the properties of other elements within that same group. So if we look at these elements in group 1A, lithium, sodium, potassium, rubidium, cesium, we see that the radius is increasing as we go down. So francium is below cesium in the periodic table. So how could we estimate the size, the atomic radius of cesium? We're not going to do anything super fancy here, but just look at the difference between 0.248 and 0.266. Can't even read. 0.266 minus 0.248 is 0.081. Yeah. Okay. Didn't mean to do that. I did it again. Try it. Okay, third time's the charm. So the difference between these two is 0.018. And so then a reasonable prediction would be that francium is 0.018 larger than the one above it. So 0.266 plus 0.018. So we might predict francium is here, and that is named after France. 0.284 is what we would predict. And you can do that with a lot of different things. Here's the density. What's happening with the density as we go down this period? It's getting bigger. And so if we needed to predict the density of francium, we'd look at the difference between these two and add that onto here. Would it be perfect? No, but it's better than wild guessing. Melting point, we see the melting point is going down. And atomic mass is going up. There's one irregularity in here, the footnote. The density of potassium is slightly less than that of sodium. So potassium is not following along here, and that happens. These are trends, they're not absolutes. Any questions? Let's do an example. Predict the missing value for each physical property listed below. So this first one, platinum, we're missing the atomic radius. So nickel, palladium, and platinum. Nickel, palladium, and platinum. They're in the same column, the same group in the periodic table. So we look at the difference between this one and that one, 0.138 minus 0.125. So there's a difference there of 0.013. So from here to here, it's going up 0.013. So then what are we going to predict for this guy? 0.151. We're going to take 0.138 and add 0.013 and get 0.151, what you guys said. How could we figure out the density of palladium? We could take the average. So we'll take 21.5 plus 8.91, find that sum, divide by 2, and we come up with 15.2. So that's what we would predict there, 15.2 grams per cubic centimeter. How about the melting point of nickel? Subtracting. We're going to look at the difference here, and then we're going to subtract the same amount there. So this, as we're going up, is going from 1772 down to 54. So it's decreasing by 218 degrees. So then we're going to take 1554 and subtract 218. And I added. It's been a really long week. I'm sure it's been a long week for you too, and you took a quiz and you're all kind of tired. Any questions? This predicting properties business is not a big deal, okay? I'll tell you, there's some things in chemistry that are big deals that you really got to get a hold of to be successful. There's others that if you're just trying to get through and pass, you could skip over. Because honestly, don't we all have things in our lives that we know we should be doing, like flossing, right, and taking vitamins and exercising? But if we do that, then we have to let something that's more important go by the wayside. You know, sometimes you have to choose between sleeping and getting your homework done. It's like, well, which one's more important to you at the time, right? So we can't always do everything. And I understand you may not have time to learn everything in this class. And so I'll point out occasionally a few things that are like, yeah, you could let that one go. This is one of those things. Dimensional analysis, not something to let go. That one's critical. You got to get that. We can also predict chemical properties from the periodic table. Members of a family, a chemical family, also have similar chemical properties. And this reminds me of my children. I have 6 children, 5 boys and 1 girl, and they have a lot of common characteristics, both in their personalities and how they look. They look like they were made with cookie cutters, pretty much, except the girl has longer hair. She's only 10. So the boys so far all love sports, play football, like to play guitar, and they just have a lot of common things, right? Are they the same people? No, they are individuals, and they have things that make them different. But just like children within a family share some commonalities, elements in a family share some things that are in common. And then they also have things that are different. So if we look at the alkali metals, group 1A, we find, oh, there's a typo. That should be a subscript. Try to catch those. We'll just do this. M2O. They all have oxides with the same formula. When lithium reacts with oxygen, it forms Li2O. When sodium reacts with oxygen, Na2O. There's a pattern here. They react in the same way. And so we can use this to predict what other elements will do. The formula for the chloride of calcium is CaCl2. What would we predict the formula for the chloride of barium to be? We'll find calcium on the periodic table. What group is it in? It's in group, calcium is in group 2. Chlorine is in group 17 or 7A. Calcium's in group 2, and where's barium? Group 2. Calcium and barium are brothers. They're in the same family. So they're going to react with chlorine in the same way. So what's the formula for barium and chlorine going to be? BaCl2. When calcium reacts, it reacts with 2 chlorine atoms. When barium reacts with chlorine, it reacts with 2 chlorine atoms. See how that works?